All right, so today is the second review class for Math 166. I will go through all kinds of problems. How many problems will be on the test? So if you look at this sample final exam, there will be 18 problems. Okay. I should say that there's still 2/3 of students don't know how to find the power series or Taylor series for a given function, such like 1/4 minus 2x. Find the Taylor series at a equals 1. Very few students, no, not very, some students learn the technique from me, like express x equals x minus 1 plus 1. But still, they are making computation mistakes. They don't know why we have to do like that. Okay, but the other student, I don't know why they didn't pay my attention to my lecture notes. Maybe never read the lecture notes, because this is the way I show them how to do it, but they didn't do it, repeat it on the test. So I don't know. You have to go through all the problems we discussed in the review class. That's my minimum requirement. Maybe you are so busy, but at least go through all the problems we discussed in the class, cover the solution, and ask yourself if you are able to do it before the final exam. Okay? Yeah, that's my requirement. And the ideas technique. Maybe we change the problem completely, but majority of problems are very similar. You know, like 1/3 minus 2x or 1/3 4x. Find the Taylor series at a equals 1 or a equals 2. Idea will be the same, technique will be the same. And if you know how to do that particular problem, and if I change the numbers, you should be able to do it. That's it, right? Right. All right, so the first problem I want to discuss is the derivative inverse function. So suppose you have function f of x equals 5x and x squared minus 5 squared, something like that. Okay, and this function, I believe that it is it has inverse. I'm not going to show that. It's not asked to prove that it has inverse function. Why is this function, the derivative is going to be negative? Okay, so the derivative is negative, so it's decreasing function over the whole interval. Okay, yeah, 5x, yeah, over x squared minus 5 squared. Okay, yeah, I wanted to find f the inverse 0 and f of that. Right? So take a look at the derivative of the function. It is going to be x squared minus 5 squared squared. Then you have a 5, and derivative of x is 1. So x squared minus 5 squared, and the minus 5x, and it'll be 2x. So let's simplify it. 5 can be taken out. I think let's get negative 5x minus x squared, because I have a negative 2x squared there. Okay. So clearly this can be always negative, right? The numerator is negative, denominator is positive. So that means this function is decreasing function, so it has the inverse. Okay, if you can solve for the inverse, okay? So this function is defined only on the interval from -5 to +5. But over that interval, the denominator is well defined, right? And the derivative is negative. So it's not necessary to say that, but you can say that f is decreasing. Then this implies the inverse always exists. We cannot say I don't have an inverse, right? But it's not, you know, it's, yeah, we didn't ask you to prove that. But it's easy to make a simple observation. F of 0 is going to be 0. So that implies the inverse, the value of the inverse of 0 is still 0. All right. So the next step is to write down the formula for the derivative. Okay. So clearly, this is going to be f prime 0. So all I have to do is just plug 0 for x into the derivative. So the 0, look at the above expression, it's going to be 5 negative 5 squared, right, minus 0, and here negative 5 squared and square. So first of all, the numerator is positive, the denominator is positive. So 5 cubed, 5 to the 4th power, it's 1 over 5. So that's a derivative at the 0. Then finally, you will get answer 1 over 5. Okay. So when you get home, tomorrow, and you look at the problems, you have 1 hour and just cover my solution and to see if you're able to do it. Right? I guarantee you get an A if you're able to do like that. Cover before the exam, cover my solution, and it goes through. You look at the problem. Are you able to do it within 5 minutes? Get the same answer. Okay. If you can do that, you will get an A on the final exam. Okay. Yes. So my next question is, we know that it's about mass of it's about the half-life of radioactive material. Right? We know that it's reduced to not, let's say 75%, okay, of the origin quantity. In how many years? Let's say in 100 years, make it simple, right? And find the half-life. Right? Something like that, Then you can also, another question could be, it takes how many years for the mass to be reduced to 10% of the original, right? Yeah. So that's the first question, Yeah. So we can, you can ask in how many years will be reduced to 10% of the original quantity. Okay. Yeah, we want to see that. Okay. So half-life, you have to find half-life. Maybe not necessarily, but for the first question, you have to find half-life. So what is the formula for that? You write on the formula. So P equals P naught e to the KT. Okay. It's decay, so you can assume K is positive, then you put a negative sign here, it doesn't matter. It's not a big deal. Okay. So that means it's decay, so K is positive number. Right? In 100 years, the quantity, this is a P of T, right? So P of 100 is going to be 75% of the original. So 75 can use a 3/4, something like that, right? And it's 0.75 and times the original, right? So this implies on the left-hand side, so there's no trick here. Just do the computation, right? So 100K. You plug 100 for T. So now you have this identity. And do you really care about the original quantity? No, because this can be canceled out. Okay. So you find the K. How do you find the K? You put the natural log on both sides, right? Natural log e to the negative 100k equals natural log of 3 over 4. Okay, so it's negative 100k equals natural log of 3 over 4. Natural log of 3 over 4 is going to be a negative number. Okay, you can also write the negative 4 over 3. That's positive. So k equals 100 natural log of 4 over 3. But that's just a k. It's not a half-life yet, right? But we find the k may be useful for the next problem. Okay, the half-life. Okay, let's forget. We forgot the definition. Half-life is when at that time t it equals the half of the original. Right? So in other words, e to the negative kt equals half of, right? And still you don't need it. Right? So the original quantity. Right, so now you take a natural log on both sides, natural log 1/2, it's -2. So half-life is actually just natural log of 2. Why have to derive again? Because I forgot the formula. Right. Yeah, that's the definition by the definition of half-life. Some of you maybe have super memory memorized the relationship between half-life and the k, but I did not remember that. So I just take a few seconds to derive the formula. All right. So now you see my motivation. Why I have to find the k? Because in this formula, the k is there, right? So it's natural log of 2 and the 1 over 100 natural log of 4 over 3. And you have to simplify a little bit, right? So it's going to be 100 natural log of 2 natural log of 4 over 3. That's it. I don't think you can write the natural log of 4 minus natural log of 3. And that's no big deal. Right? So if you have a calculator, you can estimate this number, but you are not allowed to use a calculator. So you cannot, right? That's the exact value. Right? Now you have a half-life, you have a k. I think k is enough. So you want to find a time t such that the quantity is going to be only 10% the original, right? So we are going to find the t such that p over t equals 10% of the original, just the 1 over 10, right? Yeah, we said that 10%. Let's go back. Yeah, 10%. So you can put 0.1, but it's a 1 over 10. So e to the negative t is going to be 1 over that. Okay, so that cancels out, and you put the natural log on both sides, and this will be negative negative 2. So the time t is similar to the half-life. Yeah. So the half-life is similar, just derive that. It's similar to the half-life, but the half-life of the 10 is 2. Right now it's just natural log of 10 divided by k. So as long as you know the value of the k, you can determine the time. Okay.
So you scroll a little bit, the answer was 100 ln to that, right?
Yeah. This is a positive number.
100 times ln to
ln 4 minus n. Yeah, this is a I think this is a half-life. Yes. This is a half-life. We find the k first. Once you can find the k, you get a general formula, except for the information about the original quantity, but it doesn't matter, original quantity. Okay. And then what is k? I forgot, right? I don't have some great memory. It's 1 over 100 of natural log of 4 over 3. So you just put it here. 1 over 100 natural log of 4 over 3. Right, so yeah, this is the answer. P over t tells you the quantity in time in t years, right? If you're looking for t such for which p of t is going to be 10% of the original quantity, you have to write an equation, and you solve the equation. And in the equation, you know, there is k there, right? So t equals natural log 10 over k. So, but you have to, you determine the k already, the value of k already.
Can you scroll up? I could have sworn that K had a negative sign on it.
No, k has no negative sign. Oh, well, at the very beginning, I just put a negative k t there. Just it doesn't matter because I know it's decays. So in order to have a positive value for the k, I just put a negative sign in front of the k. It doesn't matter, you know, if you just put a k, this k there, then the value for k will be negative. Right now, the value for the k, this is a positive number. Okay.
If it was an increase, would be k the same?
Yeah.
So there would be no negative if it was
Yeah, it doesn't matter. You just originally you can put a negative k there. You can put a positive k. It doesn't matter. If you just say e to the kt in general, right? Then you end up with a k equals a negative number. Okay, in the decay case. Yeah. Okay.
And why did you switch it from ln 3/4 to ln 4/3?
Well, switch. You mean here?
Yes.
Oh, I just want. It's no good reason. I just want to change the sign. Yeah, natural log of 4. I want to make sure every number is positive, visible, you know, positive. Otherwise, 3 over ln 3/4, it's a negative number. You know, it's harder to see. Yes.
Would we get much wrong if we choose not
No,
to do that?
no.
I don't know if this was, I had a different looking answer, but I feel like it's still possibly correct. What I did is sort of like the half-life, like 1/2 e.
Yeah.
Since there is a negative sign, and the term is split those so that it's 2 equals e to the ln 4/3 of 100 t. And are you allowed to take it so you can split up e to the ln 4/3 and e to the t over 100?
E to t over 1, yeah, that's so fine, yeah.
So then if you take e to the
We just look, first of all, I just look, yeah. It doesn't matter which expression, I just look at the final expression. If it's wrong, then more likely some step is wrong. I have to go back to look at, okay? But the form, the final expression, the form, they can in many different forms. You know, if this is correct, that's correct, that doesn't matter any of them. It's already in very simple form, okay? But I would prefer like this one, at least you have to bring 100 to the top, you know. This is definitely should be simplified a little bit, okay? Okay. Yeah, but if you express as 0.01 times natural, then you don't need to do that. If you write a fraction in the fraction, then you have to simplify the fraction. Yeah, that's why I make sure there's no another fraction inside the fraction. That's a general rule in mathematics when you simplify. Okay, I don't want to see 2 fractions there. You know, like a 4/3 is a fraction, right? And it's inside the denominator. So that's the reason I don't want to see that. That's the general rule. So this is why so we get 1 single fraction. Okay, so for the same reason, and this can be this should be read as natural. Yeah, there's no fractions. Yeah.
Which you could rewrite the ln of 5 over ln 2/3, correct?
5? Where is 5 from? Natural log of 10 is right. It's 10. Yeah. All right, the next question is to evaluate the integrals. Integral could be in any forms, such as x squared minus 1 squared dx. Now, don't forget put a dx there. Okay, when you evaluate integrals, I still have a habit of just don't care about the dx. Okay, for the integral. Okay, and then something like that, x over x squared minus 1 squared dx. I hope you can do these 3 type of problems. Okay, they are slightly different. They're slightly different. Okay. I'm going to write it closer because it's hard to print out sometimes. So this is the second type, the third type. Okay. The first type, the second type, and third type is similar. Okay. Depends on how do you decompose it. The third type, you still have to do the division before you do it. Okay. Because x squared over x squared minus 1, this is going to be, if you can do it directly, and that's going to be 1 plus, right? Then you get 1 plus x minus 1, x plus 1. Now, if you don't know how to decompose it quickly, you have to express it in this form, and it determines the constant a and b. Okay, but there is a standard way, quick way to do it, just x minus 1 minus x plus 1. Okay, then you find out x will be canceled out, but it created 2, so you have to put 1/2 there. Okay, but you can get a equals, you can get a equals 1/2, b equals -1/2 by the standard method. But I can see that it's going to be just minor the subtraction. All right, so once you get this, then the integral of x squared minus 1, and this is going to be integral plus 1/2. But don't be lazy. You have to put a dx there. I'm not sure who is going to grade the final exam. If you don't see that sometimes I take points off. Okay, just like you're an artist, you're drawing a picture, human portraits, right? And then you submit it, and you find out this person has no ears, that person knows no nose. Of course, you cannot get full credits. Okay, all right. So the integral of 1 is just x. Then the next one is the integral of 1 over x minus 1. It's just natural log of x minus 1, the absolute value. Right. Then the third one is going to be and plus constant. Don't forget a constant. Okay, so that's it. And the same idea, only for the first one, you have to do the long division to to get rid of x squared, because the degree of the numerator is the same as the degree of the denominator. That's why you have to use the long division to simplify. There, you cannot express like a of x minus 1 plus b of x minus x plus 1, right? So it's a long division, okay? Now, for example, if we have x squared minus 3x over x squared minus 1, you have to use a long division first, because at that time the derivative as a degree, the numerator is the same as the denominator. So you get x squared minus 3x. Here's x squared minus 1. You have to put the 1 here, x squared minus 1, and you do subtraction, you get 3x plus 1. So the remainder is 3x, negative 3x plus 1. So your answer will be 1 plus negative 3x plus 1, x squared minus 1. Then, then you know the degree of the denominator is smaller than the degree of the numerator. As the degree of the numerator is smaller than the degree of the denominator, then you can decompose it in the form. Okay, then you can determine the coefficients. But here it's harder to guess what is A and B. It's more complicated than the previous one. So you have to combine them again and determine the coefficients. Okay, so it's ax plus, ax plus 1 plus bx minus 1. So you will see that compare the coefficients. A plus b should be equal to -3, and a minus b should be equal to 1. Then from here you solve for A and B. Okay? Yeah, because this is 1 plus a plus b, x plus a minus b, x squared minus 1. So you compare those two numerators, you get these equations. Right? Then this linear equation, a plus 2a is going to be -2, so a is going to be -1. Then do subtraction, and the 2b equals -3, it's -4, so b is going to be -2. And great, okay? So you determine the coefficients, then you evaluate the integral. Yes. Yeah, I just say in case you're given a polynomial, a rational function, the degree of the numerator is greater than or equal to the degree of the denominator, you have to use a long division to simplify until the degree of the numerator is smaller than the degree of the denominator. Just you get a remainder. Then you can do the standard decomposition, right? And then you can get two linear equations for A and B, and you solve it. Be careful you solve it. Then you can then you can integrate. Okay. Then x squared minus 3x squared and dx is going to be the integral 1. A is -1. B is going to be -2. And dx. Okay. And then you write down the antiderivative. It's negative sign anyway, so I take a negative sign out. Plus constant. Step.
What's the negative?
No, I have a negative sign here. A is -1, B is -2, so it's negative. I take a negative sign out, yes. A plus B equals -3. I compare with those two because I want to decompose that. Okay, I want to decompose it to the sum of two simple terms. So I don't know the coefficients, so I combine them again. Then I compare the coefficients. Okay, get two linear equations.
In all these cases, compare with the numerator, like the value such as Right, thank you for your explanation. Say for instance,
That's always complain. Otherwise, how do I know that, right? I cannot do quickly. Like the last one, this one, I already have some experience. If it's just 1 over x minus 1, x plus 1, I know just take a difference. Then I get, if I combine them, I get 2 in the numerator, so I divide by 2. That's a quick way to do. Okay, but in general, you have to do like that. It's harder to figure out quickly. Yeah, the coefficients. Yeah, there are some few people have this talent to do that by mind. Don't need to just look at that, can quickly figure out the numbers. They can do the computation like a 5,322 times 125. Once you finish reading, they already give you the answer. Okay, it's pretty fast. I don't know. It's amazing. What happens to name 2? That time I forgot. Okay, I couldn't get 100% on this test. That's right. Yeah. I never got 100% on my calculus test. Okay. I only have one classmate, but he can always do perfect. 4 years. All the average scores on the math test is 99.5%. So only lost 1 point somewhere. I don't know. No, he's an economist right now. I have 2 great roommates. Those are my good roommates. He got 2 PhD degrees. Okay, one is in mathematics, the other one is from economics from Harvard University. But he doesn't like mathematics. All right. So this is a problem, and then another typical problem we want to discuss is integral of cosine 2x and sine x dx. Okay, something like that. Now, the reason I like this kind of problem is because there are 2 different ways to solve it. Now, you can express it directly as the sum of 2 functions, but you have to be very good in trigonometric geometry. Do you still remember the formulas? Sine alpha plus beta is going to be sine alpha cosine beta plus cosine alpha sine beta, right? Another formula, you change the sign. Okay. Oh, this is a sine beta, yeah. So in order to get cosine sine, I can use subtract. Because I memorize those 2 formulas. I always forget the other 2 formulas. That's the reason I have to derive it again. But if you memorize, that's great. The 2 sines alpha sine beta, right? So cosine alpha sine, what happens? Cosine, I'm trying to undo. Still, gosh. Whew. All right, there's no way I can get rid of it. Okay, I'm going to delete. All right, so cosine alpha sine beta is going to be half of that, right? Sine alpha plus beta then the minus sine alpha minus beta. Okay. I think when I was young, I can memorize all those formulas. When I was in high school, now I cannot. So, but I memorized the first two. I don't know why. I can always, forever, lifetime. So I derived this formula. All right. So if you know this formula, then you can see that cosine 2x sine x dx. Okay. So now it's going to be sine, the sum of the two, the 3x, and there's a difference of this two will be just x. You see? Then those are the functions, it's only single function, right? Then you find the antiderivative of each of them. But the antiderivative sign will be negative cosine. So negative cosine 3x, but don't forget divided by 3. And here's negative, and they're going to become positive. So cosine x divided by 1. And then plus constant. Cool. So this is the answer. Only probably 10% of students will use this method because it requires you to know more formulas in trigonometric geometry. Okay? Yes?
What is that cosine x over?
Cosine x over 1. It's nothing, just a 1. The stand, you know, I just put the cosine x there. Yeah. Remember, you know, sine kx, right? If you want to find the antiderivative, be negative cosine kx divided by k plus constant. Okay, so if you don't know the formulas, how can you solve this problem? Okay, there are two options. One is you view cosine x as 1 minus 2 sine squared x. Then you what? Then you end up with this like that. Then you get sine x minus 2 sine cube x dx. Then you have to trouble, you know, you forgot. You know, you remember we already did it. So integral of sine cube x. But this is it's difficult. So that's the wrong way to go. We have to use 2 cosine square x minus 1. Okay, then
First part was not the right substitution.
yeah, I cannot use substitute directly. I find out just making it more complicated. I cannot deal with this. I forgot, you know. I know we did that problem in the class long time ago, but right? You don't remember and you cannot handle it. So let's try another one because I cannot use a substitution for that one. So now if you change it, you get cosine square x sine x dx. Then you're okay because the second part is just the sine x. It's okay, right? So this one, I use a substitution. I let u to be cosine x. Then du equals negative sine x dx. Okay, so the integral will be u square negative du. Okay. Yeah, actually, put out separate.
And then you just multiply the two.
Yeah, just separate. Yeah, just separate. That's going to be 2. Just separate. That's 2 terms. All right. So the first one I can use substitution, but as you wanted to use substitution, you have to have a 2 different functions, sine, cosine, cosine, sine, right? So you can use substitution. Then the second one is the antiderivative of sine x will be negative cosine, so it's just cosine x. Forget it, right? So you write down that. So now you have a negative 2 over 3 u cubed, right? And plus cosine x plus c. So u is cosine x. So I get a negative 2 over 3 cosine cube x plus cosine x. All right, so the answer, the final answer is quite different from the previous one we got, right? But there's the same answer. So we see that you get be negative 6, right? I think it's negative 6, yeah. Negative 6, half of a cosine x. So it's surprised that this is also going to be negative 1 over 6 cosine 3x plus half of a cosine x plus another constant. Okay, so that's it. It's hard to verify, but that's it. Okay. Yeah, I get. Let's go up. I always double check, right? It's it's half of cosine x negative 1 over 6. I guarantee that's it. Only differ by constant. That's how we use the C prime, not same C. Right? The next typical problem is like such as anything like square x, natural log x dx. Those kind of, we like this kind. And there's one function there, natural log x. Other one is a power function, right? But for the first one, there'll be two possible ways to prove it. When you see natural log of square root, you can always take the radical, get rid of the radical first, right? If you do like that, then it'll be similar to the problem on the right hand. So there are two ways to do, okay? One is natural log. This is going to be 1/2 natural x over square x, okay? This will be half of x to the negative 1/2, something like that, right? All right, you're going to use, you have to, there's one problem, you have to use integration by parts to solve it. So you have to differentiate natural log u in order to get rid of this. Okay, this will be u, that will be dv. Okay, when you switch it, order, then you differentiate u, then get rid of natural log. Right? So what is a v? What is a v? I think v can be x to the 1/2 divided by multiplied by 2. So when you differentiate, you get dv. So I think it's better to put here. The 2 is inside. Okay. So you get that's a v, right? Yeah, you can put this inside here. It's a dv. Okay. Okay. So since already taken out the 1/2, I don't want to write. All right. So the answer here is uv, right? Minus integral v du, right? Okay. That's 1/2. U is natural log of x, and the v is 2x to the 1/2. V is 2x to the 1/2. Du is 1 over x du dx. So let's simplify. And here's minus, and this will be negative 1/2 dx. The entire derivative of that will be 2x to the 1/2. plus constant. Okay. So the idea is to use the integration of parts to differentiate the natural log of x. So you can get rid of natural log. This is the integration by part. Then there's a part for the derivatives. There are not many problems for the derivatives. So f of x equals the same, equals, this is a typical problem. We put there, find the derivative, right? You have to find the derivative using chain rule. But I said that many times, if you see radical inside natural log, get rid of the radical first, because it's difficult to differentiate the natural log, right? So you have to, it's going to be 1/2 natural log of x squared plus 1. And after that, then it's much easier, right? Yeah, then the derivative is going to be 1/2. Whatever inside the natural log, you have to put in the denominator. Then you have to differentiate this term, right? Yeah. And then you get 2x on the top, right? Then you simplify it to x over x squared plus 1. Okay. What we are doing here is, if you differentiate natural log of u, be careful, it's with respect to x, not with respect to u. By the chain rule, this is going to be this, right? The chain rule. Now, u is inside the natural log and another u is in the denominator, du, right? Then they match, then you can have, say, 1 over u dx. All right. The next problem is we are given the function x equals, I think I forgot, yeah, it's a sine t, cosine t, and the y. I remember for the problem on the test, right? I'm going to do this. Where's my test? Okay, so let's look at the problem number 10. Let me erase this. The problem on the test is x equals half of sine theta, y equals 2 sine theta. Okay, 2 times sine theta. And find the tangent line at the point, right, corresponding to where theta equals pi over 4. This is a very simple problem. So I think 80% of students knew how to do it, but only half of the students get the right answer. Why? That because of that computation mistakes also. Right. But if you draw the graph, very few students realize this is already a straight line. Almost nobody point out. This is a straight line. Yeah, straight line. But nobody pointed out. clearly it's a straight line because it's part of the line. The reason is y is a proportion to x. Okay, y is a proportion to x because y over x is 2 sine theta over 1 sine theta is going to be 4. So i.e. y equals 4x. So the tangent line to a straight line is the same. It's themselves. Just two lines. And I did not mean I want to do that because I forgot to change the sine to cosine. So I was thinking about to make a ellipse, but for some reason I forgot to change the sine cosine. But then after print out, I realized, oh, that's just the straight line. But no, I'm surprised nobody pointed out. Okay. Of course, if it's strict line, then you don't, all your computation should lead to slope equals 4. A strict line, what's the tangent line to the strict line? It's the same self. And it must be the same. It's 4, y equals 4x. Okay? So when you get something, don't just apply the theory directly to that problem. You have to look at the simple, think about it. Maybe it's very obvious. Okay, don't do the things without just thinking. Just that's a routine. This is the way we always handle the situation. Someday you become an engineer or become a plumber. Don't just always apply the same theory. Go solve the problem. You have to the case by case. Look at that first. Make a simple observation and then think about for a few seconds before you write down something. Okay, just like yeah.
So what do you follow? Like, you just do y over x?
No, I just say this is, then if the simplest method for this problem is you don't need to even find a derivative. Okay, I just say the curve is a straight line, y equals 4x, therefore the tangent line will be itself. Even I did not mean at the very beginning, I put the problem, I didn't want to do like this, but nobody did it like this. That's okay. Okay. So it is a straight line, right? Y equals 4x. Therefore, the tangent line at any point is y equals 4x. That's it.
You should put that on fine. You should put that on fine. Or to make up or like just change that to cosine or something.
But yeah, so let me change it to cosine. All right. So here's a point. Okay. Okay. So I'm going to change it to x equals 2 cosine theta, y equals 1/2 sine theta. Okay. Find the tangent line at the point when theta equals pi over 4. Okay. Then this is ellipse. Okay, honestly, look at that. X over 2 square plus y over 1/2 square is going to be cosine square theta plus sine square theta equals 1. I still want to see some student can point out this is an ellipse. Right? It's ellipse. Right? And you can tell whether the slope is positive or negative even. Since it's ellipse, think about that. When y0x is plus minus 2, and this will be 1/2, 1/2. That's going to be ellipse. Okay? So pi over 4 is here. Pi over 4 is here. I think yeah, when y0, I get x plus minus 2. When x0 plus minus, so it has negative slope. Negative slope. For this particular problem, it has negative slope. Okay.
So we're not gonna do it like m equals dy.
No, m equals, right? It's supposed to be dy over dx. You can use, if you solve for what? Okay, so you can find the slope at that particular point if you're able to solve for y in terms of x. But I don't want to do that. Okay, but first of all, let's find the point. Okay, the point is when x, its cosine pi over 4 is 2, square root 2 over 2 is just square root 2. Right, the y naught is 1/2 sine pi over 4 is 1/2 square root 2 over 2. So you have two numbers later. Okay, so I like to find the slope in different way. It's going to be dy d theta dx over d theta. Then let theta to be pi over 4. Okay. So y is going to be, what is y? Y is going to be 2 sine half of, right? It becomes cosine theta. And x here is 2 negative 2 sine theta. And that theta equals pi over 4. But when pi equals pi over 4, sine theta equals cosine theta. You don't need to put a variable, right? So it's going to be negative 40. Okay. Yeah, cosine pi over 4 equals sine pi over 4. So that cancels out. Okay. You just evaluate, find the derivative. Because y equals half of the sine, so the derivative is half of a cosine. Okay. Anyway, so you got slope, you got the derivative, and the equation is y equals. This is not a problem on the test, but you will probably still can cancel. No, you cannot cancel any terms. Yeah, that's it. This is the equation I like to see. Slope is negative. We see that at the very beginning. All right, the next problem to set up an integral. I hope we still remember the integral formula for the length of a curve and for the surface area of the surface generated by loading a curve around some axis. Okay, so integral that represents the length of the curve. Okay, so the curve could be in any form, right? So it could be x equals 3y squared, something like that, you know. Y is between 0 and 4. I just randomly pick up. could be x equals some function, but I prefer I change a little bit. Okay, the idea is, yeah, the graph looks like it's a portion of the parabola. Okay, this portion of the parabola, it opens y is positive. It goes like that. This is a piece we're talking about. Right? Right. So what is the formula? Okay, I only memorize this formula. Okay, that's the retrieval formula. Then how do I figure out ds, right? ds is going to be dx squared plus dy squared. And which variable I should use? I think in this case I should use a y variable, right? So I take y out, it will be dx dy, because it's easier to find the derivative of x with respect to y, right? Okay, if you are given y equals f of x, then you take a dx out, right? So yeah, so then that's going to be 6y squared plus 1, right? Then you get the formula. Length is going to be integral. Okay, let's start from negative, from y start from 0 to 4. So that's it. Okay. The next one is set up an integral. If I rotate, yeah, set up an integral for the surface area. Okay, the surface it's generated by rotating y x equals 3y squared. Okay, about the y-axis and about the x-axis separate. So you have to set up a two integral for each of them. Okay, y is still between 0 and 4. The two pictures. Draw the two pictures. This is one is this one, right? About the y-axis. Right? Then about the axis. A totally different picture. Right? Right? The same curve. Right? The same curve, right? Same curve, but the surface is different. The surface area will be different. How do you set up this formula? Well, I only memorize the surface area is going to be integral 2 pi r ds. Is that correct formula? 2 pi r the circle and ds. Yeah. So that is a formula. The length is from 0 to L. So then I apply this formula to different problems. If I work on the first problem, right? This is about the y-axis. Then what I'm going to do, I pick a point here, x and y. My radius will be this, right? In that case, radius equal to x. Clear, right? Okay, so the integral, I think the highest point, here's the point, right? When y equals, y is between 0 and 4, right? Y is 4. If y is 4, what is x? When the y is 4, I think our equation is x equals 3y. So when the y is 4, 16 times 3. 6 times 3 what? 48? Yeah, 48. Okay, so it's the same. 48. Okay. So you have to decide which variable you're going to use. I think we still have to use x. The reason is x equal, use a y variable, okay? So I'm going to use a y variable, then the integral should be 0 from 4 to pi r ds. No, I have to replace it by dx over dy squared plus 1 dy, okay? I prefer use y variable because it's easy to find the derivative. So I is going to be x. I have to replace it by y. So I is going to be 3y squared. And here will be derivative. 3y squared is going to be 6y squared plus 1. So this is our integral. Okay, very clear. Yeah, x is going to be 3y squared. Okay, if you use y variable, use a 3y squared. If you use x variable, use x. Okay, now as you may say that I want to use x variable. Use x variable is fine. If you use x variable, using x variable, then x will be start 0 from 48, right? Yeah, 48. So x starts from, it's 2 pi x, then 1 plus dy over dx squared dx. Right? Okay. So you have to find the relation between y and x, because x equals 3y squared, so y equals 1/3 x squared root. Okay. So you differentiate, and this is 1/3. I think the derivative of square of x is going to be this square dx. Okay. It looks more complicated, but it's integral. If you use a software like a Maple or something, you can check those two integrals quickly, get the same value. Okay, doesn't matter which way. Okay, so you can see that you can use any variable. Okay, in general case. So the second one is about the x-axis. If you do about x-axis, let me draw the picture again. I need a more, yeah, I have to look at it, right? So this is a point x and y, and here's the radius r. Okay. So r this time is going to be 1, and the y is going to be 1/3 of x. Okay. And this is still point 48 and 4. So which variable you're going to use? It doesn't matter, honestly. Okay. So the surface area, if you use a y variable, it's from 0 to 4, 2 pi r the y. Okay. Then it's dx over dy squared plus. Okay. And I think why use y variable is better in this case. And this will be 4y squared plus 1. Okay. You can easily evaluate this integral by substitution, because there's y squared inside radical, that's y outside. Okay. Now, if you say, I really want x, use the x variable, then the 48, 2 pi, and I equals square root 1/3 x, and you have to differentiate this, right? Then you differentiate, yeah, I equals this, then derivative of that is going to be square 1/3, and the 2 square x squared dx. It's even more complicated. Right.
You don't have to replace y for the actual root 1/3 x, or no?
Why have to reverse? Well, I just strictly using formula here. I have to figure out what is r, what is ds. This is a ds part, ds part. That's the r. Then you decide, do you want to use a y variable? It looks like it's better to use a y variable and use a y variable. Then ds should be expressed as square root of dx over dy squared. If you want to use the x variable, you take a dx out. And then be careful about the radius. So you have to draw the graph. You cannot do the problem without the graph. You have to indicate the radius in the graph. Okay. I think I almost cover the other half of the final exam. It's pretty slow. No, I'm not already. I only gave it 2 hours for the final exam. Of course, each problem I discussed with more cases here, right? Yeah, this is okay. So next class, I still go back to the series and sequences. Yeah.